Okay, so today what we're going to do is we're going to go and factor quadratics that look like ax squared plus bx plus c. Now, in mathematics, opposite operations are used to undo operations. So for example, 5 plus 3 gives 8, but then 5 minus 3 equals 5. And with 5 times 3, you get 15, but then 5 divided by 3 gives you 5, right? So essentially, it's kind of like 5 becomes 8, and then 8 can also become 5. So it's kind of undoing what the other thing did, right? It's called the opposite operation, right? Now, today's lesson is all about the opposite of expanding. So if we expand this problem here, we have x, and then we distribute the x into our bracket. We're going to get x squared, and then x times negative 4 gives us negative 4x. And then, how do we factor? Now, factor is just undoing what we just did for expanding. So in this case, we got to think about what does each of these terms have. So I need to see what's in terms of what's inside of this x and this 4x. So you'll notice that both of them could be, the first x could be written as x times x, right? And then the minus 4x could be written as just 4x. Now, both of those would have a single x. They share a single x, right? So what we could do is we could essentially pull it off or divide it out, right? So we pull it off, essentially, and then we have left over x minus 4. So if you think about it, we pull off an x from xx, you get x. You pull off an x from the 4, and you're left with minus 4. And that's what we have inside our bracket. Now, we essentially say we're just pulling off one of those x's, and then what happens in what's left in the bracket is what's left, right? We will talk about this later on when we work on a thing called common factoring, okay? And we will focus on common factoring and make sure you understand. These are supposed to be set up in such a way that we can see what is the opposite of expanding. Okay, so now for this next one, we have x plus 2 times x plus 5, right? And we're going to go and use our distributive law to get our answer, okay? So when we distribute, we get this. And now we have to pull together this stuff here in the center. When we collect our center terms, we're left with x squared plus 7x plus 10. So now, how do I go and take x squared plus 7x plus 10? You remember when we were working on expanding in lesson 1, we were talking about what the heck it was, right? And expanding, we were always saying, hey, notice something. Notice that two things multiply to something and two things add to something. So let's go and revisit that concept, shall we? So if you have x squared plus 10, the reverse of x squared plus 10 ends up being x plus 2 and x plus 5, right? That's all it is. Now, you're going to notice something kind of strange here, right? You're going to notice that 5 and 2, right? If I take 5 and 2 and I add them, I get 7. If I take 5 times 2, I get 10. All right? And those are definitely related to what we had here. Okay? So we'll eventually learn how to do that later on today. The next concept we're going to learn is dealing with something like this, where we have almost a mirror of two of the same terms, where we have x and x, or x squared minus 9. we're going to look at a thing today called a difference of squares as well, right? So if I have x squared minus 9, notice x can be written as x times x, right? And 3 can be written as, 9 can be written as 3 times 3. So I could write this as just x plus 3 and x minus 3 because this middle term gets killed off from it. And we'll talk about that later, right? Now, the reason why we call this a difference of squares is because 3 squared is 9 and x squared and x squared can be broken down into x, right? So we use that to come up with this solution, all right? So now, suppose I have x minus 3 all squared. That just means we have x squared minus 3x plus 9. When you simplify, you're going to get x squared minus 6x plus 9. Now, that's awesome, right? Now, because of that, there's a pattern here, right? So if I look at that, I could write this as just x minus 3 times x minus 3, which is equal to, well, x minus 3 quantity squared. And we'll talk about that later. This is what we call a perfect square. Okay, we'll talk about that later, is one of the concepts we'll study today. So now, let's go on to common factoring, all right? So when we're talking about common factoring, we have this thing, x squared plus bx, right? And all we're doing is pulling off an x and then telling me what's left over, okay? So basically, if you look at this problem here, both of these, I could write x squared as xx, right? And I could write this as just 8x, right? And both of them have an x, so I could pull off an x from both of them, right? So what's left over would be x and 8, and that's what's happening here, essentially, okay? So now, if I look at this next one, x squared minus a quarter x, right? You look at these two, x squared could be written as xx, couldn't it? Right? So we could literally just pull off an x. Simple. Pull off an x. So if you pull off one x, what's left over? In our bracket, we're going to be left with x and minus 1.4. And that's it. Okay? So we got x, and then we're going to subtract 1.4. Sorry about that. Made a mistake. It was too close. Okay? And we're done. Now, the questions that you have in your notes will deal with stuff like this. Okay? We will talk about it later. If there's anything that is more difficult than this, let me know, and I will send you an example. All right, let's move on. So now, let's go and factor trinomials. Okay, so you understand common factoring, we got that. Now we're going to factor a trinomial, okay? Finding the binomial factors of something really means making two brackets of everything, right? That is what I'm underlining here, okay? And we're looking for a p and q that add to b and a p and q that multiply to b. That is what this problem is telling us, right? So if we can find two numbers that add to b and then two numbers that multiply to c, and they're both p and q, then guess what? We can calculate them. We can calculate the factored form of our trinomial. So let's go over a problem and let's see if we can come up with it, right? There is a bit of what you would call it guess and check, right? So it's kind of like you have to guess two numbers that might work, and then what you're going to do after that is you're literally going to just test to see if the two numbers add to the number or the two numbers multiply to the number. If it works, then we're good to go. All right, so let's look at this one here. We have 36. So we're looking for 36, right? And 36 can be written as 1 times 36, right? But it also could be written as 2 times 18, couldn't it? It could also be written as 3 times 12. You could also write it as 4 times 9. And that's it, right? Or 6 times 6, right? So all of those possible ways we can add it, right? Now, here's the cool part. So now they have to multiply to 36, but so that is just the last number of our equation. But they must add to 36. So the key would be next to take a look at each of those numbers that we have there. 1 and 36. Does it add to 36? No. But then if you go through the list, you find out that 4 plus 9 also adds to 13. So guess what? 4 plus 9 gives us 13, which gives us the middle number of our equation, which is what we want. So we can write this as x plus 4 and x plus 9. And we are done. So let's do the same thing again for the next problem. So we have negative 18, right? So I can write this as negative 1 times 18 or 1 times negative 18, and then negative 2 times 9 or 2 times negative 9, right? Because either one of those could be negatives, right? And then 3 times negative 6, and we're done. So then we have to multiply to the last number, right? So we're multiplying to negative 18, right? That is what this problem is all about. We're multiplying to negative 18, but our number in the middle must add to positive 7. So I have to go through all of my list of numbers and see which two numbers would add to positive 7. Okay? So it's kind of like you just go and pull out your calculator and you go, okay, negative 1 plus 18. Nope, that doesn't work. 1 plus 18. Nope, that doesn't work. Negative 2 plus 9. Oh my goodness. That might work. So it's kind of like we have to go through every single number set to find what we're looking for, right? And in this case, our answer that works is going to be the negative 2 plus 9. Okay? So I tend to always write my brackets and wait, and then I go to my list of numbers and then I go and circle the one that works. In this case, the one that works is negative 2 plus 9. So I'd use negative 2 and 9 in my brackets, and guess what? We are done, right? Because 9 plus negative 2 is 7, and 9 times negative 2 is negative 18. So guess what? We have our factorization. So we can just put that directly in to our brackets. And we're literally done. Okay. So now, let's pause a minute. Okay, for this next question, you have x squared minus 13x plus 36. So that's what we got. We have a very similar problem here, right? And we have a very similar problem to this. So what we're going to do is we're going to use that same method that we did before, where we find our entire list of numbers that multiply to positive 36, but you have to note that we have a negative number in the middle, right? And the only reason why we have a negative number is because if you think about it, two negative numbers could be positive, couldn't it? All right, let's continue and see what I'm going to write here. So for x squared minus 13x plus 36, right? The middle number, the negative number in the middle, tells us that we have a negative and a negative, because if you look at 36, 36 is positive, right? So that means both numbers must be negative. So remember, if the middle number is negative and the last number is positive, then both of them must be negative, right? So we can have two negatives in this regard, right? So when we do our calculations, we're going to have to set up our candidates, right? And our candidates are basically -4 and 9. So if we went through that whole list of stuff of possible numbers that multiply to 36, I'm going to have -4 and -9 in here. So I'd have 1 plus 36, 2 times, -2 times -18, -3 times -2, and then I would find that -4 times -9 gives 36, but then -4 plus 9 gives 13. So we would do that over and over again, and this is what I expect you to do for your possibilities. But if you quickly just think in your head and it comes out right, then I'm not going to stop you, okay? So let's continue. So this one says -4 times -9 gives us positive 36, which is what we need. So we're good. We can use that. So now let's go and set up our brackets. So we've put our brackets with our empty thing, and then we're going to put in -4 and -9 as our answers. So guess what? We're good. Now for the last one. For the last problem, we've got x squared minus 7x plus 18. So just give me a moment while I resize my screen. Basically, we need a little bit of space for this because there's going to be a lot of thought going on here. Okay, so we have x squared minus 7x minus 18. We're going to do the same problems as before, right? And we're just going to use the candidates that we had up here to figure out what two numbers add to -7, right? Okay, that add to -7, but multiply to -18, right? It's the same as this one that we had before, except this time you have a minus and a plus. A minus and a plus gives us a negative, doesn't it? Right? So that means one of them must be negative and one of them must be positive. So if I go back up here, if you think about it, it's got to be one of these, right? In this case, it's going to be -9 and 2, because -9 times 2 gives 18 and -9 plus 2 gives 7. So now we can factor. Alright, and we are good. So we've got x minus 9, bracket x plus 2, and we are done. Okay, now we're going to work on factoring the perfect square trinomial. Okay, so just like before, we always looked at the last number and found all the multiples of 25. 1 and 25 and 5 and 25. So we're going to set up our brackets and we're going to factor it. Okay, so now we're just going to check. 5 times 5 is 25, but 5 plus 5 is going to be positive 10. So let's just write that down just to be sure. We think it's 5 and 5. So let's just make sure one last time. So you're going to write 5 plus 5 is equal to 10, and 5 times 5 is equal to 25. Perfect. So we're just going to put a plus in between each of these. So now, let's look at the next problem. So we have plus 16 and minus 18. I'm going to give you a hint. Because we have plus 16 and a minus 18 there, we have plus 16, we have 2 times 8, and then we also have 4 times 4, right? So here's the deal. You could go through all of these and check. Does 1 plus 16 give the middle number? No. How about the second one? Right? No. But here's the deal. We know that we can have negative numbers here because our middle term is negative and our final number is positive. So we need to have negative 4 plus negative 4 gives negative 8, but negative 4 times negative 4 gives 16. Okay? Now, just a quick hint, you might want to write this down as I say it. The key concept is this. If I have 4 and 4 equaling 8, right? But our answer must be positive 16, but our middle number is negative. Maybe what we want to do is change both our positive numbers into negatives, and that's how I came up with that. And that's how you should think about it too. Okay? All right, so let's continue. Now, I'm going to tell you these questions are not quite perfect. Because you have x plus 5 repeated, you have to write it as x plus 5 squared, and you have to do the same for x minus 4. Okay? Now let's talk about difference of squares. Okay? Alright, sorry, I guess I should say this one more time. We really have to complete that problem like that. If you see matching factors, write it as this. Alright, so x squared minus 25 for difference of squares can be written as x squared plus 0x minus 25. So here's what we're going to do. We're going to set up our bracket, okay? Okay, and then here's what we're going to do. We're going to write down all the possible factors of 25, just like last time. Okay? The last term for a difference of squares is always negative. Just remember that. That's how you know you might have a difference of squares. And I'm going to tell you right away that the answer is the square root of the middle number of the last number for both of these, right? And here's the proof. Negative 5 plus 5 gives 0, right? But then negative 5 times positive 5 is going to give us negative 25, isn't it? Right? Which is what we want. So, positive 5 and minus 5 give us the original equation x squared minus 25. So what do you think this next one's going to be? Do we really need to write the 0x bit? Or could we just come up with the final answer? Because you got to remember that the final answer is a perfect square. So if I looked at 16 and I checked it, it's x squared minus 16. I go and check. I go, okay, the square root of 16 is 4. So I really think this final answer is going to be x plus 4, x minus 4. Let's check it. So now, let's go. You're going to write x squared plus 0x minus 16, right? So this is just going to remind you that you got to have a positive and a negative of our root, right? So the square tells us it's 16, right? The square is 16, so here's what we're going to do. We're going to write this as, Willie, take the square root of 16, which is 4. And then all we have to do is make one of them positive and one of them negative, and guess what? We are done our difference of squares. Okay? Let me show you the difference of squares shortcut. Ready? If you look at x squared minus a squared, you can just write it as x minus a x plus a, or x plus a minus a. It doesn't matter. Both of them are equivalent. So for example, if I look at x squared minus 49, I can just write that right away. X plus 7, x minus 7, and we're done. Easy peasy. All right, let's move on to the next problem that we have here. This next problem asks us to find an expression for the area. Now, we're going to have to break this into two parts. The area of the big section minus the area of the smaller section. So let's do that. You know, the area of any shape, of any rectangle, is L by L, right? And a square is just a special rectangle, right? So we can just write that as x times x, which really gives us x squared, right? Okay, so a big is x squared. So now, what's the area of the small section? Okay, so the area of the small section is still length times width, right? But the area of the small section is this little bit here. So that means the area is just 91. So here's the final expression that shows me the area of the shaded portion. You're just going to go area of big minus the area of the small, which is x squared minus 81. But it says we need to factor it, right? Isn't this just a difference of squares shortcut? So it's going to be x minus 9, x plus 9. And we're done. Yeah, we are done. So that is the area of the shaded region in factored form. Make sure you highlight it so that if I ever look for your final answer, I can read it, right? If not, just write a sentence. So you'd say the area is x minus 9 times x plus 9. And we move on. Let's move on to the next problem here. Example 6. The area of a rectangle can be represented by this, right? X squared plus x minus 20, right? So let's do that. The length can be represented as by the expression x plus 5, right? Find the expression to represent the width. All right. Let's just factor this thing right away. So we need to know two numbers that multiply to 20, negative 20. So we got 20 times 1, 20 times 10, 4 times 5, right? Now my question is, which one is negative, right? I'm going to tell you. We know that 4 times 5 gives 20, right? But if I use it, one of them has to be negative and one of them has to be positive because the last number on here is a negative, right? So which one is it? Is it going to be the minus 5? Or is it going to be minus 5 or minus 4, right? So the key is we got to check. It must add to 1, right? So positive 5 minus 4 gives 1. Oh, perfect. We're good to go. So here is our length and width, right? The length is equal to x plus 5, which means the width is equal to x minus 4. And guess what? We're done. That's it.